functioning of the multi-effect evaporation plant to achieve zero liquid discharge as per pollution norms. Adiabatic evaporator. RO reject is fed to adiabatic tank. From the adiabatic tank, the RO reject is pumped to the surface and vent condensers. The condensers are used to condense vapors in the last stage of the evaporator to maintain the required vacuum in the system. During the process, the sensible heat to the liquid is used to evaporate the water in the feed, which comes to you free of cost, saving a lot of steam. The hot liquid is sprayed in the adiabatic evaporator through evaporative fills and gets cooled by the fresh draft of cold air. This method not only saves steam, but also removes requirement of cooling tower from the system. Procedure for applying vacuum in the system. Ensure that all the valves open to the atmosphere, such as drain valves, sample valves, pump discharge lines open to atmosphere are kept closed. Open all the vent valves, steam bypass valves for retaining vacuum. Vacuum of around 26 inches is attained within 30 to 40 minutes under normal circumstances. Importance of applying the vacuum in the system. The air removal from the system is decisive for efficient working of the evaporator. The air has a low heat transfer coefficient and can drastically affect the evaporation rate. Also, leakage of air in system results in lower vacuum, which in turn results in lower temperature difference between each effect, resulting a drop in the capacity. This vacuum is produced by a water ring vacuum pump connected to the condensers. Process description for multi-effect evaporator. Start the adiabatic evaporator and apply the vacuum in the system by water ring pump. Then start the feed pump. The feed flows from a series of preheaters. The preheated feed is taken to the first effect. The feed is regulated with the help of actuator-operated valves and PLC-operated level sensing devices, which regulates the feed to a desirable level, ensuring minimum condensate contamination. The circulation through heat exchanger is maintained at a high velocity with the help of a forced circulation pump, thereby reducing the possibility of scaling in exchanger tubes. The liquid gets transferred from first effect to another on account of the pressure difference. The evaporation rates are adjusted in each stage in such a fashion that the desired concentration is achieved in the last stage. Start supply of steam to the heater at the required pressure. The feed gets heated and flashes in the vessel due to lower pressure. Preheaters use the flash vapors of the hot condensate to preheat the feed close to the boiling point, thereby saving steam. The vapors generated by flashing of the liquid is taken to the next effect due to the lower pressure and used for evaporation in the next stage. In the first flash vessel, Some water from the RO reject gets flashed and is converted into vapors. These vapors are carried into the next heater's shell side as a heating media by vacuum, and again the RO reject passes through the tubes, and thus there is a heat transfer between shell side vapors and tube side liquid. Subsequently, vapors are separated in a flash vessel, and the whole process is repeated in successive stages. Generating the vapor condensate with TDS. The condensate, usually with a TDS of not above 200 ppm, can be used in a unit based on the requirement. From the last stage, the product pump pumps the concentrate for further drying operations. Based on the nature of salt and the crystallizing properties, the various options used for drying are solar pond, white or agitated thin film dryer, crystallizer with pusher centrifuge, and spray dryer.